All right, so let's debrief the first page of this Barbie activity. So one of the big themes that we're going to have here during the debrief is that our equation is used for making predictions. Okay, so the key word there is predictions. So right here in question number 1, when we write the equation, we want to make sure that we're including this symbol here above the y. This is called the hat symbol, but really it stands for the word predicted. So we would read this as the predicted y is equal to 25 and a third plus 7.46 times x. Okay. Now, what would be even better than just adding that extra symbol there is to write the equation using context. And so what that would look like is predicted distance is equal to 25 and a third plus 7.46 times the number of rubber bands. Okay. So don't be afraid to, forego the traditional x and y in your equation and use the contextual words instead. All right, question 2. This is kind of what we call a plug and chug style question. You're given an x value, you plug it in, and then you use order of operations to come up with your prediction. Okay. So same thing here, we should be putting the hat symbol above the y, because we're not calculating the actual distance Barbie traveled, but we're calculating the predicted distance based on the model. Okay. All right, question 3, we want to look at the difference between the prediction and the actual distance. It was a difference of about 1.37 centimeters. Okay. That difference is called a residual. Okay. And we define it as the actual value minus the predicted value. Okay. Now sometimes residuals will be positive, like it is in this case. Other times the residual could come out negative, right? And that would happen if the actual value was below the prediction. All right, question 4 should look very similar to question 2, with the exception of the value we're plugging in is extremely large, okay, and large relative to the data that we originally had. Okay. So we should be extra careful when we're trying to make these predictions because the value we're plugging in is pretty far from our data. And we're not entirely positive whether the trend we see here in the first 7 rubber bands would actually continue beyond 7 rubber bands. So we call this type of prediction an extrapolation. Okay. And generally speaking, it's dangerous to extrapolate since we don't know what the pattern is going to look like further down the line. All right, question 5. We're going to look at the y-intercept. So that's 25 and a third. And the way we can interpret this is, when there are 0 rubber bands, the distance traveled is 25.33 centimeters. All right, now to make this interpretation 100% correct, we really want to say predicted distance. Okay, so the predicted distance traveled would be 25 and a third centimeters. Okay. Now, the 0 rubber bands represents when the x value is exactly 0, and then the 25 and a third, that's the y-intercept value. We can think of it as an ordered pair, right? So 0 is the x value, and then 25 and a third, or the y-intercept, would be the y value in that ordered pair. Okay. I think in Algebra 1, they refer to the y-intercept as like the starting point, right? So what's the first point you plot on your graph, and that usually is on the y-axis or when x equals 0. All right. Now, the more interesting interpretation is actually the slope. Okay. So remember from algebra and maybe even calculus, right? A slope is a rate of change. right? It describes how one variable changes with respect to another variable. So in this sentence, when we add one rubber band, the distance traveled increases by 7.46 centimeters. Again, right, the main theme here is we're not really talking about distance, we're talking about predicted distance. Okay, anything related to this equation has to do with predicted distance. Okay. All right, so 7.46, that's the slope value. Okay. And let's just kind of remind ourselves how we define slope. Right, so slope is the change in the y versus the change in the x, right? Or from a visual standpoint, it's the rise versus the run. Okay. So if the slope is 7.46, well, we can write that as a ratio by just making the second number in the ratio 1. Okay. So when the x variable changes by 1, so that's rubber bands, the y variable is predicted to change by 7.46 centimeters. All right, the last question shows some computer output. Now there's a lot of numbers here, but really only 3 that you should be able to recognize. The first 2 numbers there, that's the intercept and slope that we've been dealing with in the previous questions. And then you might recognize this, that's the r squared value. It's the correlation raised to the second power. Okay. Everything else at this point you can disregard. Okay, don't worry about any of these other numbers. Okay, even the one that says r squared adjusted, not needed. Okay. All right. So let's kind of give each of these numbers some notational value. Okay. The constant, we're going to call that the a value. The slope, we're going to call that the b value. And then combined, that would give us the equation. Predicted y equals a plus bx. Okay. Kind of similar, but not quite the same as in Algebra 1 when you say y equals mx plus b. Okay, so we don't like to use m for slope. We actually like to use b for slope, which is very confusing because you used b for intercept back in the day. Okay. Also, probably should make a note that rubber bands, that's the context for our x variable. All right, let's flip over to the next page and let's just do a quick summary of the 3 main points. Okay, so remember, I said this activity is all about predictions. Okay. So first, let's write down the equation that we're using to make predictions. Okay, in general, that's a predicted y value is equal to some constant plus some value, some slope times an x value. Okay. Right, that constant is also known as the y-intercept, and the slope, I guess you can call it like a coefficient. It's a multiplier. Okay. Now when you're plugging in numbers into this equation, you just want to be careful about plugging in numbers that are really, really big or really, really small. Okay. Any of those situations would be considered an extrapolation. Okay. And remember, extrapolations are dangerous. Can't always trust the accuracy of those type of predictions. Yeah. Now, when we make predictions, we're prone to have errors, right? No prediction is perfect. So we want to be able to measure the error in our predictions. And that's what the residual does. Okay, it looks at the actual value minus the predicted value. Okay. If you want to just abbreviate these, you can use R, A, and P. Okay, residual, actual minus predicted. Okay. All right, now here in our notes we have a template that you can use to interpret a residual. Okay. So we would say the actual y context was, okay, you would put the residual value there, okay, and then above or below, depending on if the residual was positive or negative, okay, the predicted value for when x was equal to to a certain number. All right. So if we apply this to like the first page, right, the actual distance traveled was, I don't know, 1.37, yeah, 1.37 centimeters above the predicted value for when there were 5 rubber bands. X equals 5. All right. The last major thing is just some more interpretations. Again, we want to be able to interpret the slope and the intercept in our equation. All right. The first template is for the intercept. So we would say when x equals 0, and this has to be in context, right? So when there are 0 rubber bands, the predicted y context, okay, so for instance, distance is, and then you put the y-intercept value in the sentence. Okay. The second template is for the slope. Okay. So for each additional x context, so for each additional rubber band, the predicted y context, that would be distance traveled, either increases or decreases by, and then you put the value of the slope in the sentence. Now, it's probably pretty obvious to you that you're going to use the word increase if the slope had a positive amount, and you'd use the word decrease if the slope was a negative value. Okay. All right, remember, it's Wednesday, so in the interest of time, we're going to make the rest of this page homework. I'll post the answer key on Canvas, and then your guest teacher is going to distribute the next activity for you to do and work in groups.